Hello my dear students. Hi. Very good morning. Once again I am here with another show of ODA Class Better Teacher, Better Future. And in this session I am going to teach you a very important question related to the lens formula. So you know that lens formula 1 upon V minus 1 upon U is equal to 1 upon F. This is a very important, and today I'll teach you a question, a numerical, how to apply this formula in that numerical, and that numerical is equivalent to 5-mark question for your board exam. So before wasting time, let's proceed. Before going to start the numerical, let me introduce that formula. As you can see on your screen, the formula for that lens is 1 upon V minus 1 upon U is equal to 1 upon F. Then here you can say V is the image distance, U is object distance, and small f is the focal length. And what other knowledge you require to solve or to apply this formula? That is a very, very important thing, which is the sign convention. So what is the sign convention and how you have to use negative sign as well as the positive sign? Actually, the negative and positive sign that you have to use is here. First of all, you have to decide that whether the object is placed on which side. And the concept is that the distance always you have to measure from the pole of the lens. As you can see here, this is the optical center. Here you can say this is a concave lens and this is the optical center. All the distances, whether the distance of object, distance of image, as well as the focal length, all the distances must be measured from the optical point or optical center of the lens, as I can show you here as well as here. If object is placed here, suppose object is placed here, so all the light rays must start from the object itself. And if light rays are starting from here like this, and the distance measured opposite to that incident ray must be taken as negative. As you can say here, this is the light ray going like this, going like this. So whatever the distance you have to measure must be measured from here. So the distance in that side should be positive, and the distance opposite to that light ray, if you measure this distance, then it should be negative. So this is the key concept. Similarly, here you can say the distance above the principal axis should be positive and the distance below the principal axis should be negative. So this distance must be positive and this distance must be negative. In case of concave lens, the similar concept you have to use again. This distance should be negative, this distance must be positive, and here this distance must be positive. Here below the principal axis, that distance must be negative. So guys, this is the concept that you have to use to choose the sign of V, U as well as F. And one more information, as you know already, that for the focal length of convex lens, positive, and the focal length of that concave lens is negative. So we have to use all this information to solve a question. Let's see how to solve that question. And then one more thing is magnification. What is the magnification? Magnification is actually the ratio of the size of the image. As you can see, M, magnification, height of the image divided by height of the object. And positive magnification means the image is erect. Negative means it is inverted. And this is the formula. And finally, you can use V by U. So what to use for the magnification? M, magnification is equal to height upon image divided by height of object. Similarly, it's also equal to V divided by U. So we will use this formula to solve that question. Okay, so let's see the question. As you can see here, the question, a needle placed 45 centimeters. So 45 centimeters is what? This is the distance of object. It means 45 U. U is equal to 45 centimeter, a lens. But we don't have the value of focal length, whether it is positive or negative. So we don't know that whether it is concave or convex. And another information, an image on a screen placed 90 centimeter on other side of the lens. Identify the type of lens. First you have to find that whether it is concave or convex. And then you have to find focal length And what is the size of the image if the size of the needle is 5 centimeter? So this much information that you have, from this information we have to find the image distance, type of the lens, and also the size of the image. So let's proceed one by one, and this question will be asked in 5 marks, because for each and everything 1 mark or 2 mark is decided or defined. So let's see how to solve. So first you have to note the data. First thing is 45 centimeter means the value of u is equal to minus 45 centimeter, because you do have the distance of object. And then image on a screen 90 centimeter on the other side. If it is 90 centimeter on the other side, that's why that distance v should be positive, and v is equal to, as you can see here, plus of 90 centimeter. It's an easy thing, okay? And now identify the type of lens. Means for the type of lens, first we have to find focal length. If it will be positive, then it is a convex lens. If it will be negative, then it will be a concave lens. And after that, what is the size of the image? Means also you have to find height of the image. If the size of the needle is 5 centimeter, means object size is given as 5 centimeter. Okay, so let's solve this question. First of all, we have V, U and F. So we should apply the formula, lens formula, that is 1 upon F is equal to 1 upon V minus 1 upon U. We don't have the value of F, so we can write 1 upon F is equal to 1 upon V. V is given as 90, correct? And now here minus 1 upon U. What about U? U is minus 45 centimeter, right? Correct. So minus minus plus. So we have 1 by 90 plus 1 by 45. Then we further solve it. Then we'll get 1 upon F is equal to LCM. When we take the LCM, then you can see here 90, right? And then you have 1 plus 2, then you can say F is equal to 90 divided by 3, and now you have focal length F is equal to plus of 30 centimeter. So the focal length of that lens is 30 centimeter. If the focal length is plus 30 centimeter, if it is positive, means the lens is convex. So the first answer that we'll get is F is equal to plus 30 centimeter, right? Then we have to find the size also, right? So how can we find the size? For the size, we will use M is equal to first V divided by U. So M, V, we have plus of 90 centimeter. For U, we have minus of 45 centimeter, right? As we have the data, so we can say M is equal to minus 2. And similarly, we have the formula in terms of height of image divided by height of object. As we got M is equal to minus 2 is equal to height of image that we have to find, and height of object that we already have, as you can see here, 5 centimeter, then we put 5 here. Then HI, height of image, is equal to minus of 10 centimeter. If it is minus of 10 centimeter, means the final image is inverted and its height is 10 centimeter. So now we have all the answers. Let's check the answer again. As you can see, first of all, we have to identify the type of lens. So what's the answer? Type of lens? Yes. Type of lens is convex. Why? Because we have the focal length positive. And then determine the focal length. We got it. F is equal to plus 30 centimeter. Correct. What is the size of the image? So we have size of the image as 10 centimeter, right? But it is negative, right? But negative just indicates, minus sign here just indicates that the final image is inverted. And then if the size of the needle is 5 centimeter, then we have these answers. And if we want to choose from this, then obviously you can clearly see that the answer is D. So guys, this is the complete solution and the use of the lens formula. Okay. So guys, this is all for today. If you like the video, please don't forget to like and please share it to your friends and also subscribe our channel, and then we'll see you in the next video. Thank you. Bye bye. All the best.